Hello everyone, what's up? A very good morning to all my students over here. So as I'm seeing that you are already present and saying me good morning in advance only. So this is the first thing, the first motivation thing I'm getting from you, that my class is actually in front of me and they are present before me only. So thank you so much, and today is the another live session of this mega revision marathon wherein we'll be discussing few important questions of the chapter chemical kinetics. Okay dear students, so yes, good morning Akash, good morning Kartike, good morning Senthil, good morning Jatin, good morning Eshani Banerjee, good morning Vikrant. So over here I am seeing some of my regular students and some of the new students. I welcome both of you all, and yes, I believe that you are very energetic and ready to actually know about the important questions of chemical kinetics. Yes, before I start this particular session, I just want to know how many of you attempted the mock test of yesterday's chapter. Kartike is saying that he got 30 out of 40. Very good, Kartike. Keep it up. Sumit, good morning. Senthil is saying that he got 32 marks in the mock test. Good. Kartike is already saying, ma'am, our Josh is high. Yes, it should be always high. Sanskriti, very good. You scored 40 out of 40. And Ashrit Shrikar is saying that he got 32 marks. My dear students, really good. Sai Chandra is saying that he scored 33 marks, 35 marks. Okay. So you are really obeying what I actually say you in these sessions, and it's a great appreciation from all of you, because your hard work is actually being seen to me, that you all are actually studying your chapters, you are doing your preparation in a very disciplined way, and you are actually taking the advantage of this particular lockdown period. So thank you so much guys, thank you very much. So the question to you from my side is, shall we begin? Shall we begin this live session? Karthike, please don't get demotivated. Don't worry if you are weak in integer type of the question. Just work hard on those particular part. Everything would be sorted out. Okay. So shall we start our session? Shall we begin today's class? So my dear students, here we go with the first question of the session in front of you. Question is, consider the given plot of enthalpy of following reaction between A and B. So A plus B gives us C plus D. Identify the incorrect statement. 4 options are given to you, and here are the 4 options. Just I would say analyze the question, read the question very nicely in a very slow manner, so that whenever you are actually getting your answer, it should be right answer. Okay. So I just want that your approach should be correct to solve this particular question. I believe most of you will be giving me the right answer. The question is asking, identify the incorrect statement. Kartikeya said, ma'am, D is the answer of this particular question. Akash has also said D is the answer. Vikrant, Jatin, they both are, Jatin is saying D is the answer, but Vikrant is saying B is the answer. The question is asking, which is the incorrect statement? I want incorrect statement. Brotati Mukherjee has said, ma'am, A is the answer. Brotati Mukherjee has said A is the answer. Okay, most of you are saying that D is the answer. So without actually having a delay, let me actually tell you the right answer. Manisha has said A is the answer. Shreya, don't worry, you are not late. It's the first question we are on. Sai is saying that ma'am, A is the answer. So my dear students, now here goes the solution from my side. Okay. Before talking anything else, let me actually show you this particular graph in a very nice manner. Okay, so just have a keen look on the graph part. Clear, dear students? Okay. Now if I talk about the first statement over here, activation energy to form C is 5 kilojoule per mole less than that of to form D. Okay, my dear students. So first of all, we'll calculate the activation energy for C and activation energy for D. Okay. So activation energy for C, if I represent it, so activation energy for C would be, it would be equals to 20 minus 5, which is equals to 15 kilojoule per mole. Okay, so activation energy for C I have talked about. Talking about activation energy for D, it would be 15 minus 5, which is equals to 10 kilojoule per mole. So from the graph only I am saying that the activation energy of C is what? 20 minus 5. Okay, because what is activation energy? It is the minimum energy that we have to give to the reactants in order to form the product. A and B is our reactant, so we have given activation energy to these reactants, and then there is formation of product B. So how much amount of activation energy we have given to these A and B reactant to form C? It is 15 kilojoule per mole. If I talk about activation energy for D, it would be 15 minus 5, which is equals to 10 kilojoule per mole. So if I go with the first statement, activation enthalpy to form C is 5 kilojoule per mole less than that to form D. So student, activation energy to form C is 5 kilojoule per mole more than that to form D. So initial statement, that means A statement, is the wrong statement. It is incorrect statement, and the question is asked, identify the incorrect statement. So option number A would be the right answer. Okay, so yes, Brothity, you were the first one to give me the correct answer of this particular question. And yes, Sai Charan and one more, Manisha, has also given me the right answer. You three were the first one to give me the right answer. Don't worry if anyone is late, you haven't missed anything. Okay, so my dear students, if I talk about statement number C, okay, so if I just talk about statement number C and B. So B statement is saying C is thermodynamically stable product, and C statement has said D is kinetically stable product. So both of these statements, both the statements, they are true statements. Okay, my dear students, you might have studied in your mathematics class about global minima and local minimum. Clear? So this point C in this curve, it is global minima. It is global minima. Okay, and if I talk about the point D in this particular curve, it is actually known as local minima. Okay, dear students, now the point which has been regarded as local minima, it is kinetically stable product, and the point which has been regarded as global minima, it is thermodynamically stable product. Clear, dear students? Okay, I believe it has been clear to each and everyone. Okay, moreover, if I talk about product C, for product C we have to give greater activation energy, and then there would be formation of product C, so it is thermodynamically stable. If I talk about point D, over here we have to give less activation energy. Clear, dear students? So it is kinetically stable product, point D. If I talk about product D, it is kinetically stable, and whereas product C is thermodynamically stable. So B and C, they both are true. Talking about option number D, formation of A and B from C, formation of A and B from C has highest enthalpy of activation. Yes, see, if I just form A and B from C, it requires high energy, because to form C, we required high activation of energy to form a thermodynamically stable product C. Now, if we will reverse the reaction, it will require high energy, which is actually not possible, but it will be requiring high enthalpy of activation to form A and B. So B is correct, C is correct, and D is correct. I hope it's been clear to each and everyone. I hope now there won't be any doubt to just understood this particular question. Okay, dear students, I believe that this question has been understood by many of you, and most of you have given the right answers. Okay, dear students. Okay, so shall we move on to the next question now? But before that, I just want to say one thing, that you have to, what you have to do, you have to attempt the mock exam just after the session gets over, and the link of the mock test has been given in the description box. This particular information is for those students who have joined us new, and for those also who are not attempting the mock test. Okay, dear students. So now moving on to the next question, and here's the question in front of you on the screen. Okay. So question is twice of H2 in the gaseous state plus twice of NO in the gaseous state gives us N2 in the gaseous state plus twice of H2 in the gaseous state. The observed rate expression is rate is equals to Kf, that means rate constant for the forward reaction, NO square H2. The rate expression for the reverse reaction would be what? Okay. Yes, mock test is very useful, because mock test actually tells you which is your weak point and which is your strong point. Okay, so it's very compulsory to attempt the mock test. Okay, so most of you are saying that A is the right answer. Most of you have said that A is the right answer. I believe all of you are saying that, ma'am, A is the right answer. A is the right answer. But I would consider that you should give me the right answer of this particular question. Don't be in a haste. Okay, don't be in a hurry. There is no competition going on over here. It's the revision class. Okay, it's not seen clearly, so I'll just zoom this particular image. I'll just zoom it, don't worry. I'll be zooming it out. So see students, I have zoomed this particular question. I hope now it's been clearly been seen to everyone present over here. Okay, so most of you are giving me A answer, but Aishani Banerjee has given me C answer, and she's saying C is the right answer. Okay, dear students, now it's my turn because time is up. So let me solve this question for all of you guys. Okay, so here's the solution. So you have actually seen the reaction. Just have a focus on the reaction part. Clear? Now I'm talking about the solution part. See, if I talk about rate of forward reaction, so I've represented rate of forward reaction by R and F, which is given to us as Kf, rate constant of the forward reaction. Then comes NO whole square, and then comes H2. It has been given to us. This has been given to us. Okay, fine. No problem. Now you all know that if I just talk about equilibrium constant, K equilibrium. So K equilibrium is equals to rate constant for the forward reaction divided by rate constant of the backward reaction, which is actually equals to concentration of the product raised to power its stoichiometric coefficient divided by concentration of the reactant raised to power its stoichiometric coefficient. You all might know about it. So K equilibrium, that means, which is equals to Kf upon Kb, it would come out to be N2, concentration of H2O raised to power 2 divided by concentration of H2 raised to power 2 and concentration of NO raised to power 2. If I rearrange this particular equation, I'm just talking about this particular relation. Okay, so if I rearrange it, what shall I get is that Kf, fine, NO square, that means concentration of NO raised to power 2, and H2 is equals to Kb, clear, N2, okay, H2O whole square divided by H2. So I have rearranged this particular relationship with respect to the relation given to me in the questionnaire part. Clear? And it has come out to be this. I hope it's been clear to each and everyone. I have just rearranged it. And all of you know that rate constant of forward reaction is equals to what? Rate constant of the backward reaction. Moreover, rate of forward reaction is equals to rate of backward reaction. So rate of forward reaction, you all know, is equals to rate of backward reaction. Clear? So rate of backward reaction, that means rate of reverse reaction, it would be rate constant of backward reaction, concentration of N2, concentration of H2O raised to power 2 divided by concentration of H2. Okay. So which particular option is the right answer? Option number C is the right answer, and I believe that now you have understood how option number C is right. So Eshani Banerjee was the first one to give me this particular answer. Congratulations, Eshani. I'm really happy that you attempted it in a very nice manner. Okay, dear students. And yes, Parth Bharadwaj was also the first one to give me the right answer. So both Eshani and Parth, keep it up, keep up the good work, and you are really working hard. See students, you have to approach the question in a very nice manner. Don't be in a haste. Just see what actually the question is been asking to you. Okay, dear students. So my dear students, if you like this particular session, then please hit the like button. Hit the like button, subscribe the channel, share it with your friends as much as you can. Clear, dear students? And yes, don't forget to attempt the mock test, whose link is given in the description box, because mock test plays a really important role. Clear? Broadity is asking, ma'am, why it is H2 and not H2 raised to power 2. See, Ashiani, I have see Broadity, I have rearranged this particular equation. If I'll rearrange this particular equation, that means I'll make this equation like this. The equation which is given to me in the question, I'll rearrange this particular equation in this particular manner. So Kf NO square and H2. So Kf NO square and 1 H2 I have taken this particular side, okay, and 1 H2 has been left in the denominator only. That's why. Okay, so I believe it's been clear to each and everyone over here. So my dear students, shall I move on to the next question now? Just let me know. Shall I move on to the next question? Why, Parvez? What happened? What's the problem? Parvez Alam is saying no. Is there any problem, Parvez? Tell me, is there any problem? Didn't you understand this particular question? Didn't you understand? Ma'am can't understand. What happened, Senthil? What's the problem in this particular question? It's a very simple question. See, rate of forward reaction has been given to you, and we have to find out the rate expression for the reverse reaction. You all know that K equilibrium is equals to rate constant of forward reaction upon rate constant of the backward reaction, which is equals to concentration of the product raised to power stoichiometric coefficient divided by concentration of the reactant. Now, I have done that only. So, if I am talking about the product concentration, so product are N2 and H2O. And if I talk about reactant, it is H2 and NO. And I've just rearranged this particular equation only. Please, I've just rearranged it. Just multiply them. Kf multiplied by H2 and NO square, and this 1 H2 has been left in the denominator only, and Kb multiplied with N2 H2O whole square, in the denominator we were having H2. You all know rate of forward reaction is equals to rate of backward reaction. So rate of backward reaction would be Kb N2 H2O whole square upon H2. It's very simple. Okay, fine. Now dear students, without wasting and delaying much, I'm moving on to the next question, and here goes the next question in the front of you on the screen. So here goes the next question for all of you. Okay, for a reaction scheme A to B and B to C, we are given with two rate constants K1 and K2. If the rate of formation of B is said to be 0, the concentration of B is given by, Okay, so just tell me what is the right option. What is the right option of this particular question? Most of you are said that B is the right answer. B is the right answer. Most of you have said B is the right answer. But I would say that just please see what is actually the answer. Okay, so don't be in a haste. Just properly see the question. Sai has said D is the answer. Sai has said D is the answer. Okay. So if somebody is having problem in watching the question nicely, I'm just zooming it, and now you can see the actual question nicely. Shreya has said D is the answer. Sai has said D is the answer. Somrik has said D is the answer. Okay, and yes, Shreya, D. And yes, Soumya Balaji has said D is the answer. Okay, my dear students, most of you have given me random answers. Some of you are saying A, somebody is saying B, somebody is saying D. So I would now move on to the solution part for all of you guys. See, my dear students, over here we are given that A giving us B with rate constant K1 and rate of reaction R1. And B to C with rate constant K2 and rate of reaction R2. Clear, dear students? Moreover, in the question they have said that if the rate of formation of B is said to be 0, okay, so then what is the concentration of the B? We have to actually find out the concentration of the B. Okay. Now, in the question they have said that rate of formation of B, dB by dt is equals to 0. Okay. Now, can I just say that net rate of formation of B is actually dB by dt? Okay, if I write this particular thing, that net rate of formation of B, net rate of formation of B, we represent by dB by dt. Okay, and it is actually equals to K1A minus K2B. Clear? I think this particular thing has been clear to each and everyone that how it has come. It's a very simple and basic thing you must have read in the initial some classes of chemical kinetics. Okay, so net rate of formation of B, it is equals to K1A minus K2B. It's very, very simple. Okay, and you all know that dB by dt is equals to 0 given to us. Clear? So K1 concentration of A is equals to K2 concentration of B. So concentration of B we have to find out. So concentration of B would be K1 by K2 and concentration of A over here. So according to it, option number D is the right answer, and Shreya gave me the answer. Sai was the first one to give the right answer D, then Somrik and Shreya. So these three students were the first student who gave me the right answer. Akshay, yes, you also gave me, but before you, Sai, Shreya and Somrik gave me the answer D. So yes, very good, Akshay, you also gave the answer D. Okay, so I believe that now you have understood that why option number D is the right answer. Okay, why option number D is the right answer, and it was a very basic question. It was really a very basic question. Okay, and I believe that now you have got that how basic things are been asked in the examination. Clear? Whether it be JEE or whether it be NEET, such types of the questions are been asked. Clear, dear students? Ma'am, how is the third question? How is third question? I am not getting, this is the third question only, and I'm not getting, Senthil, what actually you want to ask to me. Third step. Third step means the net rate of formation of B is dB by dt. Okay, so let me do one more thing for you. I can write that rate of reaction R1. That means when we are moving from A to B, rate of reaction is R1. So it would be K1 of the A. It is rate law for the first reaction. Okay, if I talk about when we are moving from B to C, it is actually R2 equals to K2 of the B. Okay, now if we want to find out the net rate of formation of B, it would be what? It would be R1 minus R2, that means K1 of the A minus K2 of the B, and this is what I have done over here. Okay, and in the question only it was given that dB by dt, rate of formation of B is equals to 0. So K1A minus K2B is equals to 0, and the answer is over here. Clear? Yes. Okay, dear students, so shall I move on to the next question? And if you like the session, please do like the particular session, do hit the like button, do subscribe the channel and share it with your friends as much as you can. Do not forget to attempt the mock test. It's really an important part of this particular session. Even mock test is really important for every live session I'm taking over here. So mock test you have to take. Okay. Hi Weber. So I think you have joined very late. Not to worry. Fine. So my dear students, it's here. The next question on your screen. Okay. So I believe now you will be able to solve this particular question. It's a very good question, trickier question, important question, because such type of the questions are been asked in NEET as well as in JEE, both these exams. So for the reaction twice of A plus B to give me C, the values of initial rate at different reactant concentration are given in the table below. The rate law for the reaction is, okay. Yeah, my dear students, I'm just waiting for you, all of you. I'm just waiting for all of you just to give me the right answer. Clear, dear students? Manisha has said, Manisha is saying, ma'am, option number A is the right answer for this particular question. Okay. We have to actually found, Manisha, the rate law for the reaction. So I would suggest you to please check once again the solution of yours. Okay. Please check once again. So don't be in a haste. You have to approach the question very nicely. Senthil has said, ma'am, option number C is the right answer. Senthil has said, ma'am, option number C is the right answer. Okay, Senthil, now time is up, and Senthil, you were very right that option number C is the right answer. Parth has also said option number C is right. Okay. Well, Senthil, Farkat and Jairam are the first ones to give the correct answer. So these three students were the first students who gave me the right answer. That means option number 3, option number C is the right answer. Let's see how. Okay, see, just have a focus on the table. We are given with the concentration of A, we are given with the concentration of B, and the initial rate of reactions we are given with. Okay. So if I talk about R1, let R1 be the initial rate of reaction for this first data. This is the first data, this is the second data given to us, and this is the third data given to us. So if I talk about R1, so R1 is given to me as 0.045. Okay, but before that I want to tell you one thing, the rate law expression. What is rate law expression? See, rate law, if I talk about rate law, okay, so rate law expression is R, the rate of reaction, which is equals to rate constant K, concentration of A raised to power X and concentration of B raised to power Y. Okay, my dear students. Now if I talk about R1, okay, if I'm talking about R1, rate of reaction for the first data given to me, R1, it is equals to 0.045. Okay, so what would be the rate law for this R1? It would be K, concentration of A. What is concentration of A given to me? It is 0.15 raised to power X. It is 0.15 raised to power X. I am sorry, it won't be 0.15. It is not 0.15. It is actually 0.05. 0.05. I'm sorry, there is a mistake in the question. And concentration of second one, it would be 0.10. 0.10, and rest all the things are correct. Okay, so concentration of A for the first data given to me is 0.05 raised to power X. Clear, dear students? And B is also 0.05 raised to power Y. Okay, clear? So I'm marking it as first in Roman number in this particular term. If I talk about R2, so R2 is given to me as 0.090, okay, and the rate law for it would be K, 0.10 raised to power x and 0.05 raised to power y, and this is the second thing I'm writing in the Roman terms. Okay, now if I just do one thing, second equation divided by the first equation, so what it would be, just have a look what it would be. R2 by R1, so 0.090 divided by 0.045, it would be k 0.10 raised to power x and 0.05 raised to power y divided by k 0.05 raised to power x and 0.05 raised to power y. This cancels out with this. We are left with 0.10 upon 0.05. So when you will actually calculate it out, what you will get, that 2, this is, it will come out to be 2. 2 is equals to 2 raised to power x. Okay, so over here we are having in power 2 raised to power 1. So the value of x came out to be 1. Value of x is coming out to be 1. Now we have to find out the value of y. Okay, so now what is R3, rate of reaction for third data? It is actually 0.72, which is equals to k 0.20 raised to power x and 0.10 raised to power y. Clear, dear students? So it is the third equation I am marking in the Roman terms. Clear? Now if I do one thing, that third equation divided by the first divided by second equation, third divided by 2, so it would be R3 by R2, which would be 0.72 divided by 0.09, which will become k 0.20 raised to power x and 0.10 raised to power y divided by k 0.10 raised to power x and 0.05 raised to power y. Okay, dear students, now when you solve this particular equation in the same manner which I did for this particular thing, what actually you will get, that the value of y is coming out to be 2. Okay, so now if I want to write the rate law, how would I write rate law? So rate law would be R is equals to k. What is the value of x? It is 1. And what is the value of y? It is equals to 2. So rate law comes out to be R is equals to k, a raised to power 1 and b raised to power 2. So option number C is the right answer. So most of you have actually given us the right answer. That means option number C. Somebody is asking how y value is 2. Dear student Babu, just calculate it out, because see, in the examination hall you have to solve this. In the examination hall you have to solve it by yourself only. Clear? So it is not my part to solve each and everything over here. Something you have to also do. Okay, so solve it and you will get the answer. Y equals to how much? 2 only. Solve it by yourself. It is a simple mathematics over where we have to do. Option number C is the right answer. Okay, so my dear students, shall I move on to the next question now? Just say me yes ma'am. Richa is saying R3 by R2 का समझ नहीं आया. So समझने वाली इसमें कोई बात ही नहीं है. आपको डिवाइड करना है. R3 डिवाइडेड बाय R2 डिवाइड करिए और सिंपल मैथमेटिक्स को अप्लाई कीजिए. यू विल गेट द आंसर. ये बहुत छोटी सी बात है. ये सिंपल मैथमेटिक्स है जो आपको यहाँ पर अप्लाई करना है. देयर इज नथिंग जो मैं यहाँ पर समझाऊं आपको. ओके, सो श्रेया शतपति एंड ऑल ऑफ यू आर सेइंग मी दैट I should move on to the next question, and here goes the next question on the screen for all of you guys. Okay, so my dear student, just see the question once so that I can zoom it again to its normal position. The following results were obtained during kinetic study of the reaction 2A plus B giving me product. The data is in front of you and you have to actually do what? The time required to consume half of A. The time required to consume half of A is what? Okay, I hope the question is in front of you. Vandana is saying, ma'am, are you happy in our improvement? Yes, Vandana, I would be more than happy. I'll be happy more than you guys, if you show me the improvement. And it's really very good that you are improving. Your scores in the mock test are on improve and you are working hard. You all are working hard, okay? So my dear students, yes, over here I have just shown you the question and coming back to the normal position now. Okay, the time required to consume half reaction, it is what? It is an integer type of the question and you have to just tell me the integer value. Parvez is saying 3 minutes, okay. Rishik is saying 3. Is it so? The value will be becoming 3, but Shreya has said me 5 is the answer. Shreya has said me 5 is the answer. Shreya, you are the first one again. Keep it up that you are the first one to give me the right answer. Good, Shreya. Keep the good work up. I know that you are really working hard. I really appreciate you for your efforts. Then the second one who has given me the right answer is Kartike. You have also given me the right answer. The answer right is 5. Then comes Babu and then comes Sheetal. Yes, all of you are giving me the right answer. Okay, dear students. Now here goes my solution for this particular question. See, you all know that rate, if I talk about rate law, okay, so rate law is rate of reaction R, which is equals to K, A raised to power X and B raised to power Y. You all know about it very nicely, okay. So if I just go with the experiment number 1 data and if I write the rate law for this particular experiment number 1, it would be 6.93 into 10 raised to power minus 3 equals to K. Concentration of A, which is 0.10, okay, raised to power X, and concentration of B 0.20 raised to power Y. I am writing it as first equation. Talking about the second equation, 6.93 into 10 raised to power minus 3 equals to K. Then 0.10 raised to power X and 0.25 raised to power Y. And it is the second equation I am marking it. Now when you solve these two equations, either you divide 1 divided by 2 or 2 divided by 1. In any case, what you will get is the value of y coming out by solving these two equations would be equals to 0. It is now your turn to solve it and the y value would be 0 when you will solve these two above equations. Okay. Now talking about the third experiment, 1.386 into 10 raised to power minus 2, okay, which is equals to K, 0.2 raised to power X and 0.3 raised to power Y, and it is the third particular equation. Clear, dear students? Now what you have to do is divide, you can say 1 divided by 2. Okay, so when you will do so, what actually you will get is, just have a look. So when you will do so, since you know that the value of y is equals to 0, so we will be ignoring these y terms. Okay, so in front of us we will have 1 by 2. Okay, so when you will divide 1 divided by 2, the result you will get is 1 divided by 2 equals to 0.1 divided by 0.2 raised to power x. Okay, and therefore from this particular relation the value of x is coming out to be 1. Okay, now if I substitute in one of the particular given data, okay, so if I am substituting the value of x is equals to 1 and y equals to 0, suppose in this particular equation I am substituting the value of x and y in this particular equation, I will get 6.93 into 10 raised to power minus 3 equals to k, 0.1 raised to power 1 and 0.2 raised to power 0. Something raised to power 0 is always 1. Clear, dear students? So from here the value of k would be 6.93 into 10 raised to power minus 2. Value of k we have got. But now I just want to tell one thing, the order of the reaction. What will be the order of the reaction? Just substitute the value of x and y. Substitute the value of x and y in the rate law equation. So when you will substitute the value of x and y in the rate law equation, so just have a look, x plus y, which is the order of the reaction, it would be coming out 0 plus 1 equals to 1. So order of the reaction is 1. Okay, now from first order reaction, we get one particular relation that T half is equals to 0.693 upon K. But mind one thing, students, over here they are asking the time in minutes required to consume half of A. So they are asking me half of A. That means I'll divide this particular thing by half. Okay, I'll multiply it by half because the time required to consume half of A. It is not asking twice of A. It is asking half of A. So it would be multiplied by half. So therefore answer would be 0.693 divided by 6.93 into 10 raised to power minus 2 multiplied by 2, and the answer would be coming out to be 5 minutes. Answer would be coming out to be 5 minutes. So T half divided by 2. We did this only and answer came out to be 5 minutes. Most of you, especially Shreya, gave me the right answer, 5. Keep it, Shreya. Keep the good work up. Okay. So answer is 5. Okay, my dear students. I hope all of you have understood this particular question. All of you have understood this particular question. Okay, so there would not be any doubt in understanding this particular question. Okay, Somrik is saying, ma'am, last step. See, my dear student, they have asked us time required to consume half of A, not twice of A. Okay, they have asked us time required to consume half of A. Okay, half of A means 2A by 2, which is A. Okay, dear students, not twice of A. That's why I took T half upon 2. Okay, half time. Okay, so it is 5 minutes. Clear? Okay, dear students, yes, Aditya just asked me one doubt, ma'am. I don't think this is wrong. It is right only. They have asked us what? Half means T half by 2 only. Na? Yes, Deepak, half means T half by 2 only. Yeah. You are saying T half by A. So my dear students, this is the right answer for this particular question, and I am moving on to the next question. But before that, don't forget to attempt the mock test. Don't forget to attempt the mock test. The link is given in the description box below. And yes, if you like the session, please hit the like button, share this particular session with your friends and subscribe the channel. So my dear students, I'm moving on to the next question, and here's the next question in front of you guys. Okay, so the question is, for the reaction twice of A plus B into products, when the concentration of A and B both were doubled, the rate of the reaction is increased from 0.3 moles per liter per second to 2.4 moles per liter per second. When the concentration of A alone is doubled, the rate increased to 0.3 moles per liter per second to 0.6 moles per liter per second. Which one of those following statement is correct? I am just giving you only 60 seconds because this question is actually of 60 seconds. Jay will be giving you only 60 seconds. So here goes the zoom option for all of you. Just read the question in a very, very nice manner. Okay, so this is the question in front of you. I have just opted for the zoom. Okay, yes, I have zoomed it already. Okay. Okay, dear students, so yes, here's the question. I want the right answers from all of you guys. So bug up, my dear students, bug up. You can do it. And yes, I know your Josh is very, very high. You are really very, very energetic. Yeah, what is actually the answer? Order of the reaction with respect to B is 2. Yes. Most of you have given the right answer, and Parth, you are the first one to give me the right answer. Then Babu, you are also the first one. Then Somrik Dubey, you three are the first one to give me the right answer. Now Vandana, Manisha, all are saying option number D is the right answer. So here goes my solution for this particular question without wasting a time. See, my dear students, again I'll say one thing, rate law. Rate law, how you write rate law? Rate law, R is equals to K, A raised to power X and B raised to power Y. Clear, dear students? Okay, now let it be the first equation. Now talking about the data given to us. Okay, now see, 0.3 rate of reaction is increased from 0.3 0.3 mole per liter per second to 2.4 mole per liter per second. Is it clear? That means rate of reaction has been increased 8 times, because 0.3 multiplied by 8 becomes 2.4, you all know. Okay, so I'm writing it. That means 8R is equals to, now this rate of reaction has been increased 8 times when the concentration of A and B both are doubled. So twice of A raised to power X and twice of B raised to power Y. This is the second equation. Clear? If I talk about the second part of the question, when the rate has been increased from 0.3 to 0.6, that means rate has been increased twice. When only the concentration of A is doubled, twice of A raised to power X and B is as it is. Okay. Clear, dear students? Now it's very, very simple. What you have to do? 2 divided by 1. Okay. And on the other hand, do 3 divided by 1. Okay. Do these two things. What you will get? Just have a look. When you will divide this particular thing, 2 divided by 1, what you will get is 8. 8 means 2 raised to power 3, which is equals to what? It would be 2 raised to power X dot 2 raised to power Y. So when you will do 2 divided by 1, you will get 8 equals to 2 raised to power X dot 2 raised to power Y, and 8 is 2 raised to power 3. So 2 raised to power 3 is equals to 2 raised to power X plus Y. So X plus Y, it becomes equals to 3. Now when you will do this particular part, 3 divided by 1, what you will get? 3 divided by 1, 2 is equals to 2 raised to power X. So the value of X would be 1. So when value of X is equals to 1, then value of Y would be equals to 2. Okay, because I have substituted this X is equals to 1 in this particular equation. So value of Y is equals to 2. Now rate law would become K, A raised to power 1 and B raised to power 2. So order of reaction with respect to B is 2. D option is the correct option, and most of you have given the right answer. Okay, so Parth, Babu and Somrik, you were the first ones to give the correct answer. So my dear students, how is the Josh? Just tell me, how is the Josh, my dear students? Tell me, how is the Josh? I believe you all are energetic, and yes, you all are solving the question nicely. Again, I would say don't forget to attempt the mock test, whose link is given in the description box. If you like this particular session, hit the like button, share it with your friends and subscribe the channel. Okay, dear students. So here is the next question without wasting a single minute and a second in front of you. This is the question. So I'm zooming in and this is the question in front of you. I believe that it's been seen to you. So wait a minute, I'll just zoom it again so that it's been clear to each and everyone. So yes, here's the question. A bacterial infection in an internal wound grows as NT is equals to N naught E raised to power T, where the time T is in hours. A dose of antibiotic taken orally needs 1 hour to reach the wound. Once it reaches there, the bacterial population goes down as dN by dt is equals to minus 5n square. What will be the plot of N naught by N versus time T after 1 hour? Okay, it's a very simple question. I believe most of you might have attempted it. So who said? Alpesh is saying me D, Rishik is saying me D, but Chinmay is saying me C, Brautati is saying me C, Prateek Gupta is saying C. Okay, Somrik has said D. Okay, Parth has said D. Jatan is saying C. Aditya has said D. Vandana is saying C. Brautati is saying D. Okay, Jatan has said C. Okay, I'm getting all sorts of the answer C, D. C and D. You all are focused on C, D. But Phenomenal TV has said me B is the right answer. Ayush has said B is the right answer. So time is up. And my dear students, Brautati Mukherjee and Pratik Gupta are the first ones to give me the correct answer. That means option number C is the right answer. How? Let's have the solution now. See students, if I just say, I believe that all of you have read the question very nicely. Okay. So if I just say that when we move from 0 to 1 hour. Okay. So when we are in a state of 0 to 1 hour, when we are moving from 0 to 1 hour, what actually we observed? That NT is equals to N naught e raised to power T. It is like this. Clear? Okay. After 1 hour, because a dose of antibiotic which has taken orally, it needs 1 hour to reach the wound. So I can say that after 1 hour, what would happen? It is given that after 1 hour, the population goes down. How? dN by dt is equals to minus 5n square. Okay, fine, I understood it. I have to just tell you that what would be the plot between n naught by n versus t after 1 hour. So I'll integrate it now. What I'll do? I'll integrate it. Okay. So I can say that at time t equals to 1 hour, that means dot at 1 hour, n is equals to E n naught. Dot at 1 hour, if I just substitute t is equals to 1 in this particular equation, if I substitute t equals to 1 in this equation, I will get n is equals to E n naught. Okay, clear? So now if I integrate it, okay, how? That means E n naught to n. Okay, E n naught to n. Am I clear to each and everyone over here or not? Okay, so over here I would be having n raised to power minus 2 dn, which is equals to minus 5 integration. So we got E n naught when time t is equals to 1 hour, and we are getting n when time is equals to t. Clear, dear students? And over here dt. What actually I have done? I have just rearranged it. How? I'll just show you now. See, if I integrate dn by dt, okay, equals to minus 5 integration of this n square. So what I did basically, E n naught to n, and over here it was 1 to t. How? See, I have just rearranged it. E n naught n dn upon n square equals to minus 5 integration 1 to t dt. I hope I have made it my point very much clear to each and everyone over here, and I believe that most of you have understood this particular thing very nicely. Okay, so now starting from this particular point, I'm starting from now this particular point. Have a look what I'll do now. So when you'll solve this particular integration, I hope most of you can solve this particular integration. We will straight away get 1 upon n minus 1 upon E n naught, which is equals to 5t minus 1. You will get this particular thing. I believe it has been clear to each and everyone over here. Clear? Now, if I just rearrange this particular equation according to my graphs, that means I want n naught by n. So if I rearrange this equation as n naught by n, I will get 5 n naught t minus 1 plus 1 upon e. Clear, dear students? So n naught upon n is equals to 5 n naught of the t plus 1 upon e minus 5 n naught. Clear? If you compare this particular equation with the straight line equation as y is equals to mx plus c. Okay, so over here the slope m is 5 n naught, and this slope is positive value. Slope is coming out to be as a positive value. When slope is positive, obviously we will get this option number C as the right answer. We will get the straight line when we will plot a graph between n naught by n versus time t. Okay, so I have already mentioned who gave me the first answer of this particular question. Is negative marking there in the mock test? Somebody is asking. I hope that you have already seen a few points in the mock test. Clear, dear students? So I believe that most of you have understood this particular question in a nice manner, and the students who were wrong, I hope now you have got the right explanation to this particular question. Don't make mistake in the examination, in the final examination. Okay, so when the slope is negative, what you have to do? When the slope is negative, you will get option number D, but when the slope is positive, you will get option number C. Clear, dear students? Okay, so without wasting any time, I am straight away moving on to the next question, because I know your Josh is high and you have not forgot to attempt the mock test. Nobody should forget that there is a mock test after the session gets over. So yes, here goes the next question in front of you. During the nuclear explosion, one of the product is strontium 90. One of the product is strontium 90 with a half-life of 6.93 years. If 1 microgram of strontium 90 was absorbed in the bones of a newly born baby in place of calcium, how much time in year is required to reduce it to 90% if it is not lost metabolically? Okay, I believe that some of the students have recently joined this live session. My dear students, I'm really very sorry that you have missed some of the question, but need not to worry. Just focus on the questions which are coming now in front of all of you. Okay, dear students? Okay, Shalini Mehta, this chapter is chemical kinetics. Okay, dear student? So my dear student, just let me know the answer of this question. And yes, this is an integer type of the question. So I want the answer in the integer manner. See, my dear students, yes, chemical kinetics is a lengthy topic, and to make you explain each and every bit of each and every solution, it will take some time. I just don't want that my students from here go without an explanation of the solution. Okay? Yes, welcome Amruta. Yes, you are new to this class. I welcome you by my all heart means. So, just Sai has said that 23.03 is the answer. Sai, I believe that the time is up, and yes, Sai, you are the first one to give me the right answer of this particular question. 23.03 years is the right answer. Then answer is given by Pawar. Satnarayan, that 23.4 is the answer in years. I want the answer in years. So, Sai and one more, I really forgot the name. Sai and Pawar, Satyanarayan, you were the first two ones to give me the right answer. And yes, Rishik is also the first to give me the right answer. Very good. Now it's my turn to solve this particular question. Gopal Shri, yes, welcome to the class. Gopal Shri, you are new to the class. So I really welcome you by my all heart means over here. So my dear students, here's the solution in front of you. First and foremost thing which I want to explain for this particular question is, and this thing you should note it down, that another class of first order reaction is radioactive decay processes. So whenever a question comes on nuclear explosion thing or radioactive decay thing, always remember in chemical kinetics that particular equation will follow first order kinetics. Clear? So I would say radioactive decay processes, they follow first order kinetics. Always remember this first and major thing. Clear? Okay, done with this particular thing. Now from first order kinetics, a relation has been set, and you might know about this particular reaction. Okay, so from first order kinetics, we know that T is equals to 2.303 upon K log A naught upon A. Now what is A? What is A? This A means initial concentration of A. Initial concentration of A. A naught means initial concentration of A. And what is A over here? Remaining concentration. remaining concentration of A after time t. Clear, dear students? So A is the initial concentration of A and this A is the final concentration. That means remaining concentration of A after time t. So I can write it as AF, the final concentration. So this is the remaining concentration of A after time t. Clear? Now in the question only they have asked how much time in a year is required to reduce it by 90%. That means there would be loss of 90%, okay, reduction of 90%, okay, and I would then say 90% loss of initial 90% loss of initial concentration. 90% loss of initial concentration means that 10% of A naught is left at time t. That means it is the final concentration. The final concentration left would be 10% of A naught. 90% loss of initial concentration. It means 10% of A naught is left at time t. So final concentration would be 10% of A naught. Clear? So 10% of A naught. 10% of A naught means 0.1 of A naught. Okay, so the value of concentration of A naught would be 0.1 of A naught. Just substitute over here in this particular equation. So what actually we will get? That T is equals to 2.303 upon K log A naught upon 0.1 of A naught. Okay, so T would be then 2.303 upon K. Clear? Log to the base 10 of the 10. Clear? So in a way what I just want to say that T is this. Okay, so you all know log to the base 10 of the 10 is 1, so I can just remove it over here. So we have got this particular relation now. You all know that K is equals to 0.693 upon T half. Okay, for first order kinetics. So it would be 0.693. Okay, K is this only and T half is given to us as 6.93 years. T half is given to us, half life of 6.93 years. Clear? So I'll just substitute T half as 6.93, which would come out to be 0.1 over here. So K is 0.1. Substitute this K value in this equation. So our time in years would be 2.303 divided by 0.1, which would be 23.03 year. Okay, so answer is 23.03 years. Sai, you were the first one, and then Satyanarayan was also the first one to give me the right answer, 23.03. Okay, ma'am, please explain once again in easy method. See, Jatin, this is the very easy method. I can explain you. One thing you need to know about this particular question is the final concentration. See, time required to reduce it to 90%. That means there is 90% reduction of initial concentration. If 90% reduction of initial concentration is there, that means if initially it was 100, so from 100 we are reducing to 90%. That means, okay, that means if we are having 100% initial concentration. Now from that 100% initial concentration, there is loss of 90%. So 90% loss of initial concentration would be there. That means only 10% of A naught is left at time t. 10% of A naught left at time t means final concentration, which is 0.1 of A naught only. That is what I have done, and then rest is, you can see, it's very easy to judge. Okay, so my dear students, I am just moving on to the next question because it's been an hour and I have to solve 2-3 questions more for you. So I believe you have understood it very nicely. Keep your Josh high, and here goes the next question. Okay, dear students, so here is the next question in front of you. Yes, Rishik, you were the third one, Rishik, not the second one. You were the third one, I believe. So, my dear students, this is the question in front of you. And yes, don't forget to attempt the mock test just after the session gets over, dear students. Okay? Please just see the link of the mock test is given in the description box. Please subscribe the channel, hit the like button and share it with your friends as much as you can. Venugopal Rao has said, ma'am, option number D is the right answer. Option number D is the right answer. Okay. Okay, I want some more answers also. So just give me some more answers from you. Dear students, I want some more answer. Venugopal has said, ma'am, D is the answer. Somebody is saying B. Sanskriti has said B is the answer. Manisha is saying D. Aditya is saying D. Jatin Raj has said B. Manisha is saying D. Vandana is saying B. Aditya is saying D. I'm actually not Ashrit Shrikar is saying D. Shreya is said B. Karthik and Nikhil is saying B. So time is up and now it's my turn to solve the question for all of you guys. See, my dear students, the rate of a certain biochemical reaction at physiological temperature T occurs 10 raised to power 6 times faster with enzyme. So with enzyme, rate of reaction is 10 raised to power 6 times faster than without. So when enzyme is there, the reaction increases to 10 raised to power 6 times. When it is not, it's normal. The change in the activation energy upon adding enzyme is. So what is the change in activation energy when we are adding the enzyme? So first only I would say change in activation energy delta EA, it would be equals to activation energy when we added the enzyme minus activation energy when the enzyme was not present. Why? Because when we added the enzyme, the rate increased to 10 raised to power 6 times. Okay. So a change in activation energy would be activation energy when we added the enzyme minus activation energy when we haven't added the enzyme. Clear, my dear students? Okay. Now a catalyst, it provides, enzyme is a catalyst only. So a catalyst provides an alternate route for the reaction. We might have heard that when we introduce a catalyst in the reaction, activation energy decreases. My dear students, it is half the statement you have read. I am repeating it again and listen to it very carefully. A catalyst provides an alternative route for the reaction. That alternative route has a lower activation energy. It does not lower the activation energy of the reaction. So catalyst does not lower the activation energy of the reaction. It provides an alternate route which has lower activation energy. Clear, dear students? Okay. Now rate of reaction. You all know by Arrhenius equation that rate of reaction, if I talk about rate of reaction, okay, we represent it by K. Clear? It is equals to A e raised to power minus E upon RT. Okay. You might say, ma'am, this K is rate constant, but you all know rate constant is directly proportional to rate of reaction. So I did this only. Fine. So this is rate of reaction when we haven't added enzyme. Now 10 raised to, if I just write 10 raised to power 6K, because now rate of reaction has been increased to 10 raised to power 6 times, it would be A e raised to power minus EC upon RT. Clear? Mark this statement as 1 and this statement, the relation, as 2. Now 2 divided by 1. Clear? So it would be 10 raised to power 6K divided by K, which is equals to A e raised to power minus EC upon RT divided by A e raised to power minus E upon RT. Clear, dear students? Okay. So 10 raised to power 6, it will become 10 raised to power 6. A cancels with A. Now it would be E raised to power what? E minus EC upon RT. Taking the log on both the sides, what we will be getting? 2.303 log, wait a minute, 2.303 into 6 log to the base 10 of the 10. So when you will take the log on the both the sides, you will get this, which is equals to E minus EC. When you will take the log, E will be removed out, RT. Clear? So what shall I say it again? Okay, what should I say it again? That if I just rearrange this particular equation, I would get E minus EC equals to 6 into 2.303 RT, because log to the base 10 of the 10, it means 1 only. Okay, but change in activation energy delta EA is equals to EC minus E. We are getting E minus EC. Okay, so when I'll just do one thing, EC minus E. So EC minus E would be minus 6 into 2.303 RT. So therefore option number B is the right answer. Most of you have answered it correctly. Akshay, Shreya, Parth and Sanskriti are the first ones to give correct answer. So tell me, how is the Josh, my dear students? I just want the answers from you. How is the Josh? Is it high or not? Still, is it high or not? Let me know. Okay, dear students, just tell me, how is the Josh? Okay. So my dear students, moving ahead on to the next question. So here's the next question in front of you. Consider the following plots of rate constant versus 1 upon T for 4 different reactions. Which of the following orders is correct for the activation energies of these reactions? Okay, dear students. Students, just bug up because I have now 2 to 3 questions more. So I just want that you should be very, very fast. Yeah, 3 more questions are left. So don't worry. I'll be doing it very fast for you. So yes, most of you are giving me D. Manisha has said D is the answer. Akash has said D is the answer. All of you are giving me the right answer. Vinayak is saying B, D and all. So without wasting the time, I'm moving on to the solution part, my dear students. Okay. See, it's the question where we'll be using Arrhenius equation. And you all might know that from Arrhenius equation, we get a relation log K is equals to log A minus EA upon 2.303 RT. Clear? Okay, now there is actually plot between log K and 1 upon T. So when there is a plot between, that means log K and 1 upon T, this particular thing I'm talking about, 1 upon T. Okay, clear, dear students? So what would be the slope then? Because if I just equate this particular relation with the straight line equation y is equals to mx plus c, I get my slope m as minus EA upon 2.303 R. Clear? So from the plot, what we conclude? From this particular plot, what we conclude? I'm just zooming this particular plot. I have zoomed this particular plot. Okay. So from this particular plot, what actually we are getting is that slope I'm talking about. Okay. Slope of C is greater than A, which is greater than D and which is greater than B. Okay. Slope of C is very negative. Slope of C is very negative. Slope of C is very negative. Okay. And if I just judge it magnitude wise also, so slope of C is very negative and magnitude wise also it is high. Magnitude wise is also high. Clear, dear students? Therefore, activation energy for C is very high. Therefore, the option number D is the right option. That means activation energy for C is high, then A, then D and then B. Manisha, Akash, Sumati and Prakash are the first one to give me the correct answer. Keep it up, girls. Keep it up, my guys. Keep it up. Very good. Keep it up. I'm really happy that you gave me the right answer for this particular question. Because from the graph only we can judge that the slope of C is very negative. And if we see magnitude wise also, it is very high. So activation energy would be high for the C. Okay, dear students, fine. So I am moving on to the next question now. And yes, don't forget to attempt the mock test whose link is given in the description box. And keep your Josh high. Okay, so here is the next question in front of you, my dear students. Here is the next question. So yes, question is saying, consider the given plots for a reaction obeying Arrhenius equation. Okay, and I believe that most of you will give me the right answer of this particular question. Okay, yes. Come on guys, come on, just tell me the answer of this particular question. I'm just waiting for your answers. Just let me know the answer. Pratik has said, ma'am, A is right. Pratik, do you really think that first is right and second is wrong? Do you really think so? Okay, Anshul has said A, Chandru has said A, Aditya is saying A, Varshit saying A. I don't know how you are saying that A is the right answer. I want the right answers from you students. I want the right answer. All of you are saying the right answer is A. Is it so the right answer is A? See, this particular question came in JEE exam 2010. Okay, so this question, Shreya has said B is the right answer. Shreya, really very good. I'm really the fan of you. I'm really a fan of you, Shreya. You always give me the right answer. Keep the good work up, Shreya. You're really working hard, Shreya. Sai has also said that, ma'am, answer number B is right. Ram Babu, Yedla has said answer number B is right. Sanskriti is saying answer number B is right. Okay, Bratati, is it not visible? I've actually zoomed this particular option. I've zoomed it. I think it's been visible. Not visible, ma'am. I don't know. There might be a problem from your side, yeah, dear. So all of you are having focus. So it's my now turn to just tell you the solution. So here goes my solution for all of you. Just have a look. See, you all know that K is equals to A e raised to power minus EA upon RT. You all know this this particular thing. Okay, so talking about the first particular plot, K versus EA. K versus EA. Okay, so K versus EA over here is actually meaning that there is e raised to power minus x graph. Okay, so this first graph, it is of e raised to power minus x. Okay, जो ये पहला ग्राफ है, it is exponential decay graph. It is exponential decay graph. Okay, so it is over here K versus EA, and this EA is the power of e raised to power minus x. Okay, so it is an exponential decay graph. Okay, so when you will plot K versus EA, you will get the first graph to be the right graph. If I talk about the second graph, there is an equation log K is equals to log A minus EA upon 2.303 RT. Clear, dear students? Now, my dear students, if I increase the temperature, then this whole particular value will decrease. If temperature increases, this whole particular value decreases. Okay, and this particular value is decreasing from log A. ये value log A में से कम हो रही है, ये value log A में से minus हो रही है. Clear है, dear students? So अगर ये log A में से minus हो रही है, what we are actually getting, that our K value is increasing, rate constant is increasing. So when we increase the temperature, rate constant K increases. Okay, when we increase the temperature, rate constant K increases. Therefore plot number 2 is also right, and hence option number B is right, that both 1 and 2 are correct options. Both 1 and 2 are correct options. Okay, Shreya, very good, dear. I'm really what should I say? I'm really the fan of yours now. Shreya, Satpati and Sanskriti, they are the first one to give me the correct answer. Really good, Shreya. Jatin is saying, ma'am, please explain it again. See, Jatin, listen it very, very carefully. Now, when I talk about plot number 1, it is between K and EA. And this EA is the power of E, exponent. This EA is the power of exponent. That means e raised to power minus x. Whenever we talk about e raised to power minus x, that means we are talking about exponential decay. So this first graph is of exponential decay and it will move like this. Okay. So whenever there is a plot between K versus EA, that means you will get this one. If I talk about second, over here, just see this particular second relation. When I decrease the temperature, this whole term, when I increase the temperature, this whole term decreases. That means ये जो term है, it has been decreasing from log A. log A में से ये value कम हो रही है, ठीक है, log A में से हम इस वैल्यू को कम कर रहे हैं. एक तरह से देखा जाए, अगर T इंक्रीज कर रहा है तो ये पर्टिकुलर टर्म, ये होल टर्म कम हो रही है. दैट मीन्स log A में से कम वैल्यू को हम माइनस कर रहे हैं. अगर log A में से कम वैल्यू को हम माइनस कर रहे हैं, दैट मीन्स व्हाट, log A log K बढ़ेगा. अगर log A में से मैं कम वैल्यू को माइनस कर रही हूं, दैट मीन्स log K बढ़ेगा. दैट मीन्स अगर टेम्परेचर इंक्रीज हो रहा है तो रेट कांस्टेंट भी इंक्रीज होना चाहिए. ओके, सो माय डियर स्टूडेंट्स, हाउ इज द जोश? एंड हियर इज द नेक्स्ट क्वेश्चन in front of you on the screen. So this is the next question. If a reaction follows the Arrhenius equation, the plot ln K versus 1 upon T, okay, ln K versus 1 upon T gives a straight line with a gradient minus y unit. The energy required to activate the reactant is, see this versus will come in between them. Okay, dear students, I hope there won't be any problem. So you would all know there is a relation that K is equals to A e raised to power minus EA upon RT. I have given you the hint and I believe most of you will be giving me the right answer. Broadly has said, ma'am, B is the answer. Badal is saying me, ma'am, B is the answer. How come B can be the answer? I really don't know. I don't know. Where are you all going, dear students? Solve it and just say me. Shreya, I'm waiting for your answers. Broadly B. All of you, Shreya has said C is the answer. Keep the good work up, Shreya. Yes, you are right, Shreya. C is the right answer. Okay, Phenomenal has said C is the right answer. Rishik has said C is the right answer. So, my dear students, Sumati has also said C is the right answer. Yes, C is the right answer. Have a focus on the equation I have provided. I have given you the hint. I don't know what you all are doing. See, my dear students, you all know that K is equals to A e raised to power minus EA upon RT. So, when I just have log on both the side, I will write ln K is equals to ln A minus EA upon RT. Okay, dear students, I have to plot the graph between ln K versus 1 upon RT. Okay, just compare this equation with y is equals to mx plus c. On x-axis we require 1 upon RT. 1 upon RT has been required on x-axis and on y-axis is ln K. So our slope is negative. And if slope is negative, it would come like this. And slope negative, it is equals to minus EA. In the question we are given, gives a straight line with a gradient minus y. So it is equals to minus y. Clear? The energy required to activate the reactant would be the activation energy. So EA is equals to y. So answer would be y. This is very simple. Okay, energy required to activate the reactant is activation energy only, no? Which is equals to y, and slope is equals to minus EA. Gradient given is minus y, so it would be y only. Okay, dear students. So yes, I am not tensed. I am just seeing that it was a very simple question and I don't know how all of you gave me the wrong answer. Dear students, please, you have to focus on the question part. If you will do so in the examination, you will have negative marking. You lost your marks and every 1 mark is also very crucial in the exam. Jatin getting confused. Why, Jatin, you are getting confused? I don't know. It's very simple, yeah. It's very simple. Don't get confused. Just chill, relax, be patient and just have a focus. मेरे इस पर्टिकुलर लेक्चर को एक दोबारा से सुनना, इस पर्टिकुलर क्वेश्चन को दोबारा से सुनना मैंने क्या बोला है, ठीक है? So ma'am, graph makes me confused. Don't worry, okay? So my dear student, now I am moving on to the, I believe this is the last question of the session And yes, I'm moving on to the last question. And yes, don't lose your energy. Be energetic because you have to attempt the mock test also, dear students. Don't forget to attempt the mock test just after the session gets over. Okay, dear student. So here goes the last question for all of you. So before we attempt the last question, I just want to make one announcement to all of you that tomorrow's session will not be at 11 a.m. Tomorrow's session will be at 5 p.m. in the evening, and the chapter which I will be discussing with you would be surface chemistry. So tomorrow is 4th April and the tomorrow's timing for the session would be 5 p.m. in the evening of the chapter surface chemistry. So be ready for it. Okay, so don't forget that you have to join me tomorrow in the evening sharp at 5 p.m. Okay, dear students. So just solve this particular question. It's a very easy question. Jatin, thank you for your appreciation. Yes, my dear students, I am personally attached to you all now. I just want that all my students over here who join me shall crack JEE exam. Okay, dear students. So here's the last question in front of you. It's a very easy question. You have to substitute the values and give the answer. Surface chemistry is very easy topic, and straight away JEE exam as well as NEET exam, they both exams ask direct question from this particular chapter. It's a very easy chapter. Okay, dear students. So just tell me the answer of this question. It's an integer type of the question. I'm waiting for you guys. Okay, dear students. Karthik is saying start engineering classes also, otherwise we will miss you the next year. My dear students, it is really a great appreciation from you that you want me as your teacher in your engineering classes also. Thank you so much. It is a big appreciation to me. Thank you so much. So my dear students, tell me the answer of this particular question. I just want the answer from you. It is an integer type of the question. Rupam is saying minus 165.49. Is it the answers will come in negative value, Rupam? Just please check your answer. Will the answer come in the negative value? I think you have done a very small mistake. Shreya, again you are the first one to give me the right answer. It is 166. So Rupam, it would be 166. Whereas the answer would be 165.707 and the approximation would be 166. So Rupam, there is slight mistake of negative. Negative will not come. Just have a look. Kalyan is also saying minus 166. No, it won't be minus 166. It would be 166 or 165.5. Okay, dear students. So it would be positive. So here goes the solution for this particular question. You all know there is a relationship when we talk about Arrhenius equation. K is equals to A e raised to power minus EA upon RT. Clear? Now what is actually happening? If I just write it down like this, log to the base 10 K1 upon K2, clear, it is equals to EA upon 2.303 R. Then it would be 1 upon T1 minus 1 upon, it would be 1 upon T2 minus 1 upon T1. Clear, dear students? Nothing you have to do. You have to now substitute the values in these particular equation and you will get the result. Okay, so what you are going to do is log to the base 10. What is the value of K1? It is 2.5 into 10 raised to power minus 4. K2, it is 1. It is EA upon 2.303. Okay, and what is the value of R? 8.314. Clear? 8.314. Clear? And 1 upon T2 is 800 minus 1 upon 600. Okay. So I think you will able to solve the log values also. So it would be log to the base 10 2.5 minus 4 log to the base 10 of the 10. Clear? It is equals to EA upon 2.303 into 8.314. It would be 600 minus 800 divided by 600 into 800. I hope this is also clear to each and everyone. Solve it. What answer you will get? the value of EA. The value of log 2.5. The value of log 2.5 would be approximately 0.397. You can solve this log value as this like this also, means you can just do log 25 upon log 10 and you can do it. Okay, so log 2.5 value would be 0.397, then it would be -4. Okay, and just calculate it out, and the value of EA would be coming out to be 165.707. so approximation would be 166 kilojoule. Okay, see, this value is will be coming out as in joule. You have to convert the value of joule into kilojoule. Okay, because it is 8.314 joule per Kelvin, so the actual value will be coming out in joules, but you have to convert into kilojoules. Divide the actual value with 1000 and the answer would be 166 kilojoule. Okay, dear students, I hope it was a very basic question. You all have given the right answer to me, and I believe there won't be any doubt. Yes, Sai, answer is 166. Okay, dear students, I believe that this particular session has benefited all of you, and yes, this particular session will bring a great improvement in your calculation, as well as when you will attempt the mock test, you will actually see the improvement in your marks also. Okay, so don't forget to attempt the mock test just after the session gets over. That means at 12:35 PM you have to actually attempt the mock test, whose link is given in the description box. Okay, my dear students, so all the very best for your mock test. Keep up the good work hard, and yes, keep your Josh every time high so that you can crack your JEE Main exam. So my dear students, goodbye, or very goodbye. Be safe at your home. Take a good sleep so that your mind and your brain is very sharp. And yes, you have to get up early in the morning every day so that you are energetic the whole day. Bye bye, dear students. Bye Hardik, bye Jatin, bye Shreya, everybody, bye. And yes, don't forget, yes, if you like the session, tell me that how you like the session. Okay, hit the like button, subscribe the channel, and share it with your friends. So my dear students, bye bye, take care. We'll meet you tomorrow sharp at 5 PM in the evening. Bye guys, bye bye.